Good morning. Today we're going to be looking at how to convert an existing Java model class to its functional equivalent using Swift. So we can start doing some more Swift-based iOS programming. And in order to do that, we want to practice using our existing knowledge, something we've already made in Java, and take that same project and be able to convert the basics of that so we can actually understand the same structural components that we'd use to do that in Swift. As you can see right here, we have our class and Eclipse that we've already made at the beginning of this year for our MarshmallowMonster project. We're going to take that MarshmallowMonster project now and we're going to convert it from its Java structure to the same functional structure in Swift. As you can see right here, we have our header, we have our declaration section with all of our data members, we have our two constructors, one with 2 parameters, one with 7, and then below that we have our getters and setters for the class. So we're going to take that same basic approach here in Java and convert that to a functional class in Swift as well. So in order to make sure I'm not using any of the help from Xcode so it can identify things for me and help, and you guys are also using PCs, I'm going to use the text editor so we can just get the idea of the showing. It's not going to give us any keystroke or any helper for that, so that we can show off what we're doing and move from there. So we have our text edit, we've got our basic thing right here, and we're not going to worry about a package for the Swift class, we don't have to have that line. We have a header still for our class, and just like in Java, our header is public class and MarshmallowMonster. And we add our squiggles, of course. Again, I'm keeping with our class standard of keeping them vertically aligned. You can, in Swift, have them aligned to different patterns. Different people like different things. Like I said, though, I like them vertical, so we keep them that way in class. Our declaration section is going to be a little bit different inside Swift. Instead of having the visibility, the type, and the name, as we see in Java, we're going to have our data members written as var, the name of the variable, a colon, and then type. And again, remembering with Swift, we don't use the semicolons at the end of every line that we've been so friendly with inside Java. So for that private string name, it will convert to var name colon string. The same for double. It'll be var number of legs and colon double with the capital D. And we'll repeat that process for all of our things. Yes, I know the hair count probably should have been an int, but you could have your hair cut. So, that's how we get the double, right? So we get parts of hairs. Yeah. And we have our var I count. And it is also of colon int, capital I. And our boolean for has belly button is going to be of colon bool with a capital B. So it's a little bit different there for the structure. But the same basic idea of actually having them declared for a class variable, something you can access throughout the class, still exists. And it has the var as the key, and then the key for the first keyword, identifying it's a variable that's one that can be changed. We have then the name of the variable, in this case name, number of legs, hair count, eye count, etc. And then after the name of the variable, we have a colon and its type. Remember, Swift, though, does not require a type on it. We could simply just say var name, and then later on assign it to a string, and it would then assume at that point that the name is a string. But because I like to know what things are when I'm using them in advance, we assign them the data member type right here of the colon string, since we know that the name is a string. And so we might as well keep it defined as a string throughout the class. And then for making our constructor, inside Swift, our constructors are not named. Instead, our constructor is the name init, and then parens, and then whatever parameters that will belong to it. So it's not init MarshmallowMonster, or init this thing, that thing, the other. It's simply init and then the parameters inside the parens that belong to it. And so in this case right here, we have our first parameter, our first constructor or init method. We have string name and double number of legs as parameters. And so when we put the init together in Swift, the same idea approaches that we did with our data members, where it is the name of the variable and then colon type inside that, separated by commas, just like we do in Java though. So we have name colon string and then number of legs colon bool, double derf. And inside Swift, instead of using the this keyword to identify the current object we're working with, Swift uses the self keyword to identify its current object. So self dot, same dot reference, so we can go into the object. The dot works the same across Java and Swift for this, as well as C# and many other languages. So we're going to go inside the self object, and we're going to say that self.name equals name, no semicolon again, And self dot number of legs equals number of legs. And so our constructor in Java that we have right here with a this dot name is name and a this dot number of legs equals number of legs converts to the init, passing it name colon string and number of legs colon double for its types. Fairly similar, but a bit different, obviously, as its structure. The same rule will apply for doing the more complex or the larger constructor with all the other parameters. Again, it's just init, parens for the values, the squiggles again line up vertically, and we'll have the name colon string, number of legs, not number of legs, number of legs, colon double, and then hair count, colon double, and eye count, nose count, colon int, arm count, colon int, and finally has belly button, because everybody knows that you need to know if you have a belly button or not, colon bool. And just a reminder, Swift, unlike Objective-C, uses true and false for its Boolean types. My personal favorites. Instead of using the yes-no that we saw in Objective-C, we get to keep it with the idea of true or false that we would use in regular Java. I think a little bit easier to read. And so again, instead of this.name, we do self.name equals name, no semicolon, self.number of legs equals number of legs, self.hair count equals hair count, self.eye count equals eye count, self.nose count equals nose count, self.arm count equals arm count, and self.has belly button, of course, to has belly button. So we pass those parameters inside from there to that inside the init method. Again, the init, not method, but the init is the constructor. It is what builds the object in Swift. Just like we have a constructor, however, init in Swift is not named like we have named constructors inside Java. So making sure you put that in your notes that we keep track of that. It's a bit of a difference from those two languages. It's one you want to make sure you practice and remember as well. Our methods are quite different in Swift versus Java. And so we'll start off with making our getter and setter for getName, and we'll continue that throughout the rest of them just so we can get the practice for it. There are some simple ways to do different types of getters and setters, but for practice purposes, we're going to write these getters and setters out manually because we can, and it's a good way to practice how to actually define what a method is and how to get used to writing them. So for a void method, or for a return type method, we have here with getName, it returns a string inside Java, public string getName. And so we have the visibility, the name of the method, and then visibility, the type of the method, and then the method's name. We have the same idea, but it's instead, again, no worrying about visibility for this. We will simply say that we have the keyword func to identify that it's a function. We will have the name of the method, getName. It takes no parameters, so it will have an empty set of parens. And then to indicate that it returns something, we use the idea of the minus sign and greater than symbol together, aka an arrow, to identify that it's returning a value. And then after that, we identify the type. In this case, it's a string. We had to add our squiggles in, again, keeping our class standard of having them match vertically. And it's return name. So the structure of a return method inside Swift is fairly similar to that of a method inside Java. The biggest difference, of course, is we have that keyword func right here. That keyword func identifies it as a method. It is separate from what we have for init. There is no func on init. Inits are not funky enough for those, perhaps. We have getName, same as what we would have inside Java over here. We have, instead of the string type like this, where it simply is between the visibility modifier and the method name, we have the idea of this arrow bracket that identifies it's a return method. And then we identify the type it returns after that arrow bracket symbol, or arrow symbol. The structure, though, inside the method is exactly the same. It returns a name. To do the void version, aka the setter for this, We'll do the approach right here. We'll say func, and we'll do set name. Again, keeping our naming conventions that we used inside Java. We'll write that up for this as well. And instead of having a return type of void like we would see inside Java for public void set name, and inside the parameter it would have a name string instead of string name, we have in here again the idea of self.name equals name. So the structure of a void method is similar to that of a method that returns a type. However, instead of having a return type of void like we have in Java, of a method that returns nothing, we do not even use the arrow indicator for return type. The absence of the arrow indicator after the method parameter set indicates that it is a void method. It returns nothing. The same beginning, however, looks the same. Get name, set name, just difference on that. And as this takes a parameter, we use that same structure of the parameter we saw in the inits, where it is the name of the variable, space, colon, type. So we can identify what it is, and then its type. And if there are multiple parameters, again, they are separated just like they are in Java and most other languages, with commas between each of the parameters. So we'll go ahead and do that for all of our different data members right here. We'll make all of our getters together, just like we do regularly. And so func get number of legs, parens, arrow bracket, or arrow indicator, arrow symbol, and then it returns a type double. Because you could have partial legs, it does happen. And again, same standard return, return and number of legs. We'll make another func. It's the get hair count. Parens. It also returns a double, so we do arrow indicator and double with a capital D. Give it our squiggles, and inside the squiggle, return hair count. Again, we don't have to worry about our good friend the semicolon in Swiftland. Javaland has an obsession with semicolons. Swiftland does not. And so if you notice right here that we're not using the idea of the pointer you would see in Objective-C where we have to return a pointer to a method type or an object type. We simply return the type itself. A little bit easier to work with and understand. One of the many advantages of Swift as a language over its predecessor Objective-C. Not unt, it's an int. And so we've got our nose count, again returning, and finally our arm count for the types of numbers. The arrow indicator, the keyword it's returning, and our last of our getters, return has belly button. So as you can see, we have that same basic structure of code for our getters across this. It has the get prefix. We can write that just like we do inside Java to keep track of things. We, instead of having an indicator before the method name, we have our indicator afterwards where we use the arrow symbol and then the type we are returning. And our internal code for that method looks just like what we do in Java, where it's simply return and the method return and then the variable name for that method. So if we do more complex methods, that would look the same approach though, where it's func, method name, parameters if needed, and then it's return type if applicable. We do our logic in there just like we would do, and keep that going. We have our setters as well, and so we get our setters. To make this go a little bit faster, we're going to take a bit of time and do some copy pasta here. I recommend, however, you do not do copy pasta, that you go through and actually type this up and change these as necessary, because that gives you your muscle memory, making sure you can remember what we did. And so this will be set number of legs. Because the practice of doing this actually does help give you a better idea of what you're doing. And copy pasta really doesn't save that much. As you can see, I'm writing down everything basically over again. Okay, so as you can see, we have our setters right here. Again, going through that, we have the set name, name colon string, self.name equals name. Repeating that for the set number of legs. Again, we use that same process where we have the variable name, colon, and then type, not doubled. But so we have number of legs of type double, hair count is of type double, eye count is of type int. We're repeating that process all the way down through that. We're passing that parameter into its value. Again, instead of Java with this dot, we use self dot. However, with Java, we have a semicolon in every line. As you can see here in Swift, there is a lack of semicolons. Every method is prefixed with the keyword func to identify it as a method. We have our init, which acts as a constructor for this. We have multiple parameters passed to it, and we go through inside here. We have our init with 2 parameters, the same idea. This one would give us a warning, however, right here on this init name colon string, number of legs colon double, because the data members for hair count through has belly button are not defined. And so we would actually need to go through, and inside of this method right here, Java will allow us to leave methods undefined, or leave variables undefined inside that. Swift will give us a warning about this, saying, hey, these are not defined yet, you need to define them. And so we'd actually need to go through, and even though they're not passing as a parameter, go through and say self.hairCount equals 0, etc. Because the idea on this is that Swift wants to make sure that it is safe to use those values throughout the actual execution of the code. And so I'd have to go through, and even though I'm only passing it the 2 parameters, I would still need to, in the in the init section, assign values into it for the data members that belong to the class. So Swift wants to make sure that all of its data members are defined, even if they're not being passed as a parameter. And that would be something to definitely put inside your notes. Thank you very much for catching that. I forgot the nose count. Again, I had to put that nose count in there so it doesn't cause a problem with my compiler. Obviously, it would cause a problem down here on nose count colon int, had that not been fixed. And if I was actually writing in Xcode, it would have caught that a while ago. But to show you this, again, we're looking at the idea of building our muscle memory and our eye memory for this. We can look for things, looking for patterns. Pattern matching helps us in looking at code. So Swift is not as lenient as Java. If we have a limited parameter init, we still need to assign values to those variables that are not specified inside the parameters. Otherwise, we will get errors. So if I had an init with no parameters, I need to initialize all the data members for that class. This one right here, since it initializes every single one of them, I simply pass those parameters, the values that are passed to the init method or the init itself. Our methods that return a type, specified with the func keyword, its method name, the magic of the arrow indicator, followed by the return type as a type. String here, double again, int, and bool. The same structure, whether it's a compound object or otherwise. If we're using one of Swift's advantages that can return a tuple, you would simply specify that it's a tuple and returning that. But we'll cover that in a later lecture. For void methods, or methods that do not return a value, it is simply func and then the method name, followed by the parameter list that belongs to that method. So that's the comparison of how to write a Swift version of a Java class. We take our existing Java class and we convert it into the idea of a Swift class with the same structure. Now for a model class, this works very, very, very easily. The structural components of the model are going to be the same across languages. I could do the same type of conversion on C# class, the same type of conversion on a Python class, and that would be honestly a fairly similar approach that we would take to actually put those 2 different sets of classes, language, objects together. However, when we're looking at the other components of our Swift project, the view controller and the app delegates and protocols that we have versus interfaces in Java, versus activities in Android, those are a bit different, and we'll do those in a separate lecture because those require a different set of language constructs and actually use more components that would go along with this. That being said, quick review. Class headers. Basic class headers are the same. Keyword public class, keyword publics in class, name of the class. We align our squiggles vertically. keeping our declaration section together. Because these variables can be changed, they are specified with var. If they could not be changed, we would use the keyword let, and that would be one where we'd assign the values only once. Our inits are the functional equivalent of our constructor. However, in Java, we have a constructor with 2 parameters and leave the unused data members uninitialized. That same rule does not apply for Swift. If we have unused or undeclared values in our parameters, we must initialize those in our init, the functional equivalent of the constructor. Keep on saying constructor. Remember that. It's the init, though. If we have a full parameter list on our init, we go through just like that, where we assign those values inside it. Inside Swift, we use the self dot convention instead of the this dot convention of Java. Our methods all start with the keyword func. We still use our parens. If it's a return type, it has the arrow indicator or arrow sign, followed by its return type itself. The internal of a return is simply return. If there's interior logic that goes along with that, that would be built along on its well. And going along the lines down to a line to a void method. The setName method takes a parameter of a string. We still assign just like we did inside the init, and it has the same basic vertical structure of squiggles we've been using all year long. Thanks for learning how to do conversion between a Java model class and the same to Swift. Have a great day, and we'll talk to you later.